Hello, I'm Paul Beckwith, and in this video I'm going to talk all about the global warming vulnerable tipping points, or tipping points in the Earth climate system. Climate change would better be called climate mayhem or climate breakdown, because it's not a linear, smooth, gradual process. It's an abrupt, highly rapid process, highly nonlinear process, where you reach a threshold and then suddenly the system moves from one stable state to another stable state. So a good example of this is the Continental Drift. So the big continental plates that move very slowly past each other or under other ones or over other ones at the speed of a few centimeters per year. Occasionally they get kind of stuck and they move slower, and pressure builds up in the Earth's crust, and when you exceed the stress limit of the rock and material, you can get a sudden movement, sudden fits and starts of these continental plates, and that gives rise to earthquakes, causing tsunamis possibly. Okay, so that's a very nonlinear process. Well, the atmosphere is essentially the same way. As we get incremental changes to greenhouse gases, as we get rapidly increasing or accelerating changes in the system responds linearly at first, but you cross a tipping point and it becomes highly nonlinear, just like the continental crust. But our response, the human response to climate change, is linear, smooth, and gradual. Often it feels like one step forward and two steps backwards. It's way too feeble. It just doesn't cut it. It will not work in the complex systems like climate change. I'm talking about the coupling of the atmosphere and the oceans and the biosphere and all the different components of the climate system. It's clearly a complex system, and complex systems try to reach some sort of equilibrium state. And we've been fortunate enough to be in an equilibrium state until recently. Okay, there was incremental change with global warming / climate change, but now we're seeing wrenching disruptions in the system as the system looks to flip from one stable equilibrium state to another state. Often these flips are one way, they're irreversible, at least on the time scale of us. It's often much easier to push these systems past a tipping point than it is to push them back over or to stop the wrenching changes occurring once you've passed this threshold. And then it can lead to things like cascading feedbacks, where one thing causes another thing. For example, we lose Arctic sea ice, Greenland melt goes way up, sea level rises globally, Antarctic ice is lifted up and destabilizes. So it's a cascading chain of events that can occur. Often nonlinear systems display something called the critical slowing down. That's in the frequency of the oscillations. This is a common sign that these complex systems are approaching their tipping points. Okay, you can get some rising variability and the response of the system slows down. Our world targets for, many countries are talking about cutting back on carbon. They're not doing it actually yet, but they're talking about it. They're talking about net zero by 2050. That's the big new term that they're using, net zero. Net zero, you have to be very careful. It can be a bit of a trap, because it's basically added greenhouse gases to the atmosphere, subtract removed greenhouse gases. So to reduce the added greenhouse gases, you need rapid decarbonization of society. And to remove additional greenhouse gases, you need to draw down carbon from the atmosphere or the ocean. You need to do both, actually. So this is why they're talking about net zero. They're assuming there'll be some magical technology that can remove vast amounts of greenhouse gases. Okay, so this technology doesn't exist, and we need to put tremendous efforts on ways to draw carbon out of the atmosphere. Also, they keep talking about 2050. That's 29 years from now. That's way too far off. It passes the buck it shunts responsibility to future generations that are assumed to still exist. But it looks like we're screwing things up so badly that you can't assume that will happen. So we need some of the things that people are looking at is carbon capture and storage, where you capture the carbon that is emitted at source from, say, a power plant or a cement factory, and you sequester it deep into the ground. Direct air capture, DAC. There's a number of different companies working on that, and there's some models that are operating, and it's been in the news recently, but it's taking out such a minuscule amount of carbon. The question is, can these things be scaled up? And of course, nature, the world systems, whether they be the animate systems, so the living systems, the biosphere, or the inanimate systems like the soils and the rocks, the capacity of those systems and the ocean to absorb the gases that we produce is threatened. Okay, these carbon sinks are threatened, and if these carbon sinks all start to fail, then it will be taken out of human hands. Okay, we're going to be on this roller coaster ride, which will have great difficulty in slowing down or halting in any way. Okay, so there's all of these factors. So I'm going to talk about the tipping point. So let's get right to the figure here. Okay, so these are, where did this come from? Okay, first of all, what got me on the tipping points, the idea of the tipping points, is there was an article by Monbiot in The Guardian that said that Earth's tipping points could be closer than we think. Our current plans won't work. Okay, so that was the kernel that got me onto this topic. And this is if I go to the tipping points website from climateemergencyinstitute.com, Peter Carter's site on tipping points. There's some images here. I just want to use this particular image here, and you can just go Google images and put global warming tipping point, and if you're in Google Images, and you get all these great diagrams. So this is the diagram. So the Arctic, of course, is a huge region where the Arctic sea ice is going very, very rapidly. The Arctic is warming much, much faster than the rest of the planet. We're losing Arctic sea ice. This year, it's interesting because the extent we're just passing. I mean, we're mid-September almost, so we're passing the Arctic sea ice minimum, and there is ice up there. It's not a record low extent, but the ice is extremely thin. Now, when we lose the Arctic sea ice, of course, Greenland ice sheet is exposed, and we can get huge melting from that. That'll raise global sea level rise, and that will further destabilize the Antarctica ice sheets. Of course, the permafrost or tundra in the Arctic is thawing. There's big sinkholes appearing. There's a lot of CO2 and methane being emitted from the thawing permafrost. We've got also the methane clathorates that are in the seafloor. And as the ocean water increases and if it thaws out the seafloor, then these clathrates can be released, and that will be, massive changes to the Earth climate system. Of course, the boreal forests are, there's regions where they're drying out, and there's tremendous numbers of wildfires going on. Now, as bad as the wildfires are, there's still a small percent of the actual total tree coverage. And, I question whether when the boreal forest, when there's imagine wildfires being 10 times worth, 20 times worth, 40 times worse, will there be enough ash and, one summer to actually cause a significant temperature decrease? Think of these nuclear winter scenarios. You can Google them. Now, of course, because the Arctic is warming much faster than the lower latitudes, the jet stream is slowing down and becoming wavier. The crests are going further north, the troughs are going further south, and it's getting stuck in place, and it's causing extreme weather events. Okay, we're getting massive droughts in these regions when you're stuck under a ridge, and we're getting many storms and torrential rains in the troughs of these jet streams. So we're already seeing big droughts in North America. There's methane clathrates, not just up in the Arctic, but at some lower latitudes too, under the seafloor. The Atlantic thermohaline circulation, or the AMOC, Atlantic Meridional Overturning Circulation, is slowing down by about 15-20%. That can have, if it shuts off and reconfigures into a pattern that's at lower latitudes, then the equatorial region will heat up because less heat is being taken from it, and Western Europe, Eastern North America will get significantly cold. We've got things like the Indian monsoon. Some years it's much very intense, and other years it's much less subdued. We have the monsoons in Africa changing, the amount of dust coming from the Sahara and so on changing. We've got the ENSO, the El Nino Southern Oscillation. There's some idea that maybe it will stop, that oscillation will stop occurring as we get warming above a certain level. Of course, the Amazon rainforest is under great threat, both from the Brazilian government at the moment, but also, from forest clearing, from farmers, and, wildfires as well. The reefs are threatened. We're getting bleaching of coral reefs around the world as the ocean is heating. The ocean is heating. It's undergoing acidification and deoxygenation. That's affecting the marine biological carbon pump, which brings lots of carbon. It's one of the reasons the ocean is such a big sink of carbon, because of these type of biological pumps. So if the ocean becomes much warmer and stratifies, and there's less vertical mixing, there's less oxygen and carbon going down, and that can have huge impacts on marine life. And of course, the ice in the West Antarctic ice sheet looks like it's destabilizing, and also we're actually getting problems with the East Antarctic. So we've got all of these different tipping points, and they all happen as part of a system. So when some of them tip, it can cascade into other ones tipping, and so on. Okay, so what is this article actually talking about? Earth's tipping points could be closer than we think. Our current plans won't work. So this is George Monbiot in a Guardian article. So basically, climate policies commit us to a calamitous 2.9 Celsius of global heating, but catastrophic changes can occur at even 1.5 or 2. And we're actually seeing that. I mean, we're just over 1 degree, 1.1, 1.2, and this summer has been incredibly, the climate's been breaking down, and there's all kinds of signs that we're seeing around the planet this summer. So this is just an image of a flash flood And I'm going to continue in a part 2 and start here and go into this in detail. Thanks for listening.